Chapter 3 is about figuring out how do we know the formulas of different compounds. And so one of the things that we can do is we can look at the percent composition of different compounds. And so again, there's kind of two common ways of describing a chemical formula and the composition of that chemical compound. One is to think about it in terms of what are the atoms that make it up, and the other is to think of what is the percent by mass of the elements in it. And so when we're thinking about the percent by mass of our composition for that, we're going to look at each of the elements that are involved. So let's say we look at this example of ethanol. So we can tell from this formula, and we can think about this formula as representing two either atoms of carbon, or we can think about it as 2 moles of carbon. So I'm going to think about each of those elements that's in there, carbon, hydrogen, oxygen, and I want to figure out what mass is in there. And so I can tell that I have 2 of my atoms of carbon, and they would each represent a mass of 12.01. So I'm going to multiply basically the subscript times the mass in order to get the total mass in the compound that comes from carbon. So 24.02, and then I'm going to go ahead and do that for the other parts. So hydrogen, notice that hydrogen's split into two spots, but it is 6 total times 1.01, so 6.06, and then we have 1 oxygen times 16, and we can obviously multiply by 1. So then we're going to add those up. We're going to total those up to get the mass of the whole compound. Oops. Get the mass of the whole compound. So in this case, that total is 46.08. And then what I want to do, my next step, is to figure out basically what percentage is each of these elements contributing. So to do that, I'm going to take my mass that I found for the element, and I am going to divide it by the total, so 46.08, and then multiply by 100 to turn it into a percentage. And so if I go ahead and do the same thing for each of them, I would be able to figure out the percentage that each element contributes to the mass of that compound. And so in this case, 52.13% is coming from carbon, okay? And so I know that this has 52.13% carbon when I look at this compound. Okay, so let's try another one on your own. So in this case, it's talking about a compound called carvone, which is actually something that we talked about last year. If you remember, before we left for the remaining part of the spring, we looked at an example of carvone that smelled like caraway seeds, like rye bread, and another one that smelled like spearmint oil, and it was really just because of the way those atoms were put together, it created a different shape that therefore created a different smell. So let's go ahead, pause now, and try to solve this problem where you're figuring out the mass percent for each of our elements in that compound. Okay, so hopefully you've tried the problem now and you can see your comparison of work to mine. So if you take a look at your work, hopefully you got to the same point, and your final answers then, you should have ended up with 79.94% for the carbon. You should have ended up with 9.41% for the hydrogen, and for oxygen it would have been 10.65%. So remember, really percent here is ending up being our unit. Yes, we could have, think of these as 10 moles, and we could think of this as grams per mole. And then these would end up just being our grams. So, we can think about those units along the way. I've dropped them off because ultimately we're ending up dropping them off and turning it into a percentage. I'm just really thinking about that part out of the whole. Let's try one more and see how you do on another example. In this case, we're thinking about penicillin. So Alexander Fleming discovered the importance of penicillin, and penicillin F has this giant formula. So take a minute, pause the video, try solving this one on your own to compute the mass percent for each element. Okay, so you should have done work that looked something like mine. Again, your total mass for the compound should have been 312.42. You're going to divide each of the masses for each individual element by that total and then multiply by 100. So for carbon, you should have gotten 53.82%. For the hydrogen, I should say, that is going to be 6.47%. For the nitrogen, that is going to be 8.97%. For sulfur, you should have gotten 10.26%. And for oxygen, you should have gotten 20.49%.